Alright, so today we're going to talk about integration by parts. And integration by parts is another one of those techniques of integration where you have to kind of figure out when you're supposed to use it and when you're not supposed to. Now, we've dealt with, at this point, multiple types of integration from regular integration to U substitutions, integration by partial fractions, integration by separation of variables, integration by parts is kind of one of those where if you have a product that you can't get rid of inside an integral, the first thing you still want to try is you want to try U substitutions. But if those don't work, then you do this integration by parts. So if you have an integral of the form u dv, which really just means if you have an integral that you can't solve that potentially has a product in it, where u and dv are functions of x, one option, and again it's an option for integration, is to separate the product using integration by parts. U dv equals u times v minus the integral of v du. Now, that doesn't mean anything to you right now. It will in a moment. So here's basically how that is going to work out for us, okay? What we're going to do is we're going to take an integral. If you kind of look at the integral at the bottom of the page, x times e to the x. We're going to separate x times e to the x dx into u and dv and then do a bunch of stuff to break it down, okay? Now, what that means is I have to take this product and I have to call part of it u and I have to call the other part dv. And you can't just guess, there's a logic to it. So to determine which one's going to be u, you use this LIATE to help you organize. L stands for logs, I for inverse trig, A for algebraic, T for regular trig, E for exponential. So you go through the list and you see which one you see first, okay? So if I'm going to do this x times e to the x down here, let me get a little purple pen here. So if I'm going to do this x times e to the x down here, I want to pick what my u is going to be. So I'm going to look for logs. Are there logs in here? Nope. Then I'm going to look for inverse trig. Is there inverse trig in here? Nope. Then I look for a. Is there algebraic in here? Algebraic means like x to a power. Is there an x to the power here? Absolutely. So u is going to be x. Then everything else from the integrand becomes dv. So e to the x dx becomes dv. Now, to use the integration by parts, we'll call it a formula, to use the integration by parts formula, once you have u and dv, you need to use them to also calculate v and du. So when I come back down here, why has that got the circle? If I come back down here, if u is x, then du, the derivative of x, is 1 dx. If dv is e to the x dx, then v, the antiderivative of e to the x, is e to the x. Now you might be thinking to yourself, wouldn't that antiderivative have a plus c? It would, but trust me, it doesn't matter. We don't need to go into all the background, but basically you just want to take a basic antiderivative here. So you first, step one, determine u, use LIATE to help. Let the rest of the integrand be dv. Create du and v by differentiating and integrating. Now we're going to rewrite the original integral using the integration by parts formula given above. So the integral of u dv equals u times v minus the integral of v du. So the integral of x e to the x dx, u dv, equals u times v minus the integral of v du. Now what just happened here? We took an integral that we didn't know how to solve. We kind of half solved it in the front here, and then we created a smaller integral in the back here. The hope is that I can actually integrate this one in my head, which I can. So x e to the x stays x e to the x, and the antiderivative of e to the x is e to the x plus c. So the integral of x e to the x dx is this. Pardon me. Okay, so what we did is we basically took an integral that had a product we can't get rid of, separated it into two parts, one that's kind of half the antiderivative, the other one we have to evaluate. We evaluated it, we got an answer. Now let's convince ourselves that's the answer. Let's do a check on this thing. So if we were going to check this, I would say, all right, if this is actually the antiderivative, then the derivative of x e to the x minus e to the x plus c should be the integrand, that original x e to the x from over here. So let's try it. The derivative of x e to the x is a product rule. The first times the derivative of the second, plus the second times the derivative of the first. The derivative of e to the x is e to the x, and the derivative of plus c is 0. X e to the x plus e to the x minus e to the x plus 0. Hey, that's what I needed. So it works. There is your antiderivative. Okay, so let's do it again. X cosine x dx. All right, so the integral of u dv equals u times v minus the integral of v du. Step 1, figure out what u is using LIATE. Now you might be saying to yourself, how in heaven's name am I going to remember LIATE? Well, one of my students reminded me and said, hey, you know what works? LIATE is retail backwards, but without the R. So that's one way to remember. LIATE is retail backwards without the R. Another student many years ago, and I still remember this, sang it in a song. And he said LIATE, like this little mathematical monk. So if you can remember retail backwards, drop the R, or I'll sing again for you, LIATE, then maybe you'll remember it. So coming back here, I have to do LIATE. Do I see logs? Nope. Inverse trig? Nope. Algebraic? Yes, I do. I have an x there. So u is going to be x, and then everything else is going to be dv. Then du, the derivative of x, is 1 dx. The antiderivative of cosine x is going to be sine of x. And the integral of u dv equals u times v minus the integral of v du. So x sine x stays the same. The antiderivative of sine x is negative cosine x plus c. So the antiderivative of x cosine x dx is x sine x plus cosine x plus c. And if we want, we can go back and quickly check our answer. Is the derivative going to give us back our integrand? Let's try it out. Is that actually going to give us back our original integrand? I think it will. Product rule here, the first times the derivative of the second, plus the second times the derivative of the first, plus the derivative of cosine, which is negative sine, plus 0. These guys cancel. X cosine x on the left equals x cosine x from the right. So, one more time, integration by parts. You separate it and call one part of it u and the rest of it dv, and then you use the integration by parts formula. All right, turn the page. We're going to do the back. X squared sine x dx. So LIATE. So on this one, we're going to let u equal x squared. That would make du 2x dx. dv is going to be everything else, sine of x dx, which means v is negative cosine of x. Okay, so the integral of u dv equals u times v minus the integral of v du. And I'm going to clean that up a bit. So we have negative x squared cosine x plus 2 times the integral of cosine x times x dx. Uh-oh. I have another product I can't get rid of. Well, you know what we go do here? We just do integration by parts twice in the same problem. So for this one, I'm going to do another substitution. U, L-I-A-T-E. U is going to be no logs, no inverse trig. Here's an algebraic. u is x. dv is everything else. And then du is going to be dx, 1 dx technically, and v is going to be sine x. So I still have that negative x squared cosine x. I still have the 2, but this integral is now going to become the integral of u dv equals u times v minus the integral of v du. So then I'm going to distribute negative x squared cosine x plus 2x sine x. The antiderivative of sine x is negative cosine x. There's a negative there already, so I'm going to make it a plus cosine x plus c. Distribute my 2, negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. And that is the antiderivative of x squared sine x dx. Now I'm not going to go through and check that. If you really want to, you can check that yourself. And now let's move on to example 4. Alright, so the example 4, we have the integral of ln x dx. Well, why is this an integration by parts? I kind of had mentioned integration by parts is mostly for when you have a product you can't get rid of. There's really not a product here. Well, that's true. Technically, there is kind of a product here. It's the product of ln x and 1. But you're still thinking that's not a product we can't get rid of. Here's the problem, though. Do we know the antiderivative of ln x? Well, I do. I'm literally paid to know that. But do you know the antiderivative of ln x? No, you don't. So we can use integration by parts to help us figure that out. So the way it works is this. We say, all right, I have ln x dx, which is kind of like ln x times 1. L-I-A-T-E. U is going to be ln x. Go away, taskbar. I don't need you. So u is going to be ln x. dv is going to be everything else. So technically 1 dx. You don't have to write the 1, but I'm just doing it for a placeholder. So then du, the derivative of ln x is 1 over x. The antiderivative of 1 is going to be x. Pardon me. So then I have the integral of u dv is u times v minus the integral of v du. U times v minus the integral of v du. Okay, moving on. So I have x ln x minus the integral of 1 dx. The antiderivative of 1 is x. So x ln x minus x plus c. The antiderivative of ln x is x ln x minus x plus c. Again, you could check that if you want. I'm just going to move on. Number 5, same idea. I have the integral of inverse sine x dx. Technically, it's not a product, but it's something I don't know how to integrate. I know the derivative of inverse sine, and so do you. If you don't, make sure you memorize that. I know the derivative of inverse sine, but I don't know the antiderivative. So we're going to do integration by parts again. L-I-A-T-E. Logs, nope. Inverse trig, yep. That's going to be my u. So inverse sine x is going to be u. dv is going to be everything else. So then I have, let me try and get rid of that box there. Go away, box. So then I have u and dv, the antiderivative of 1 is x. Pardon me. And the derivative of u, the derivative of inverse sine, is 1 over the square root of 1 minus x squared dx. Alright, so the integral of u dv is u times v minus the integral of v du. Alright, well this looks kind of yucky. I'm going to rewrite it. So x inverse sine x minus the integral of x over 1 minus x squared square rooted dx. Well, how do I take the antiderivative of this one? Now I have a quotient, and this isn't a quotient I recognize. This is integration by parts with a nested u substitution at the same time. Hooray! This would only be better if it involved logarithms. So now we're going to do a u sub. U is going to be the inside, pardon me for all the coughing, u is going to be the inside 1 minus x squared. Du is going to be negative 2x dx. You're going to not need the negative 2x, I just need 1. So I'm going to multiply by negative 1/2. So this is going to become the integral of u to the negative 1/2 du times negative 1/2, which is going to become add 1 to the power, divide by the new power, put that negative 1/2 back, which is going to become negative, let's see, what was my u? 1 minus x squared. Negative the square root of 1 minus x squared plus c, and then this is still here, x inverse sine x minus that. So long story short, the antiderivative of inverse sine x is x inverse sine x minus the square root of 1 minus x squared plus c. That's weird, but it's true. And that is integration by parts. So long story short, what we just learned is integration by parts is great use of a technique of integration for when you have a product you can't get rid of, or you have a single term that you just don't know the antiderivative of. Use LIATE to find u, and then fill everything out in the formula from there. That is all. Thanks for hanging with me, and we are done.